rotating cube. In this exercise, we consider a cube, the unit cube, the length of which is equal to 1. We have to give a sketch in a matrix form. Then we'll try to make it rotate around some angle and some axes, and we have to illustrate using Python. So the sketch is a matrix in homogeneous coordinates. That's why here I only have 1 on the last line. And here I have some points. First point, second point, third point, and so on. So let us see what this means. The first one, 0, 0, 0, corresponds. So here I have x, here y, and here z. Here it's my first point, this one. Now the second point is 1, 0, 0, it's here. And these two vertices make an edge, so this edge. Okay, so now the third point is 1, 0 for y and 1 for z, and it is this one, and so on. So this means that I can draw the whole cube without lifting the pen. So for instance, the solution could be this, and let's say this, and I have to come back to some edges I have already done. Okay, so maybe here it's not an optimal solution, but I have here a matrix with 16 points, and probably it is this one could be the minimal number of edges I need to be able to draw the cube without lifting the pen. Here it is a Python program which makes it possible to draw a three-dimensional picture of my cube. So I define the sketch, so U, so here it's U, like a unit cube. In homogeneous coordinate, I create my figure, I draw my axes, x, y, and z, here. I give the scales, -3, 3, and so on. Then I draw my axis here. And then I will call the drawing function with a cube. So the drawing function is given here. It calls a plot of matplotlib, and it takes the 3 first column. This one corresponds to m of 0, the second one to m of 1. So m here is u, since it is the argument of the function. I switch to Python. This is my program. I run it, and I can see here my axis. My axis with a cube. So the axis is red, green, blue, and the origin is this point. So now in the exercise, I have to make it rotate around an angle theta with respect to the OX axis. I want my cube to turn like this. So for this I need to use a rotation, and the rotation formula we use in homogeneous coordinate is the following. We build the rotation matrix by the exponential using the Rodriguez formula, which tells us that I have to take 0 minus omega z, omega y minus omega x, 0, 0, 0, excuse me, here it's omega x because it is Q symmetric, minus omega y, omega z, and the diagonal is 0. So this corresponds to the rotation matrix, thanks to the Rodrigues formula, around omega, like this, with an angle corresponding to the norm of omega. So now, once I have the expression of the rotation matrix, to be able to rotate u, I will have to form the homogeneous rotation matrix as follows. I take this, so it is 3 lines, 3 columns, and I have to add 0, 0, 0, 1 here, and 0, 0, 0. So now this matrix is now 4, 4, and I can multiply this rotation matrix in homogeneous coordinate by u. So I can make this product RH multiplies by u, and this will make rotate my sketch u to form a new sketch corresponding to the rotation. So since I have to turn around the OX axis, I can, if I prefer directly, have an expression which corresponds to this. So it means that this, this, in our specific case, corresponds to that. They are equal. So they are equal, of course, is omega here is taken as theta 0, 0. Okay. So this I will now make a Python program for this, which is given here. Which is very similar to the previous one. But now I will make a continuous rotation in a for loop. So the program is the same as previously. U is a unit cube. I create my axis and the figure. And this is my for loop where t corresponds to theta. Okay. Rot h corresponds to this matrix given here, and it is in the Autolib library. I make the multiplication by u so that S corresponds to the rotated sketch. Then now I clean, I erase the previous picture. I draw the axis again, and then I will draw the rotated sketch. I switch to Python. It is now this one. I run my program, and I see my cube rotating around the x-axis, which is here red.